Okay, so this is the lecture for Chapter 2, Section 1, Describing Motion. All right. Notice the essential questions. You should be able to answer these when you're done. Here's your review of vocabulary is meter, motion, displacement, and speed are our new vocabulary terms. Make sure you're studying the vocabulary terms. I'll try to put them up because we will have a quiz over this, okay? All right. So describing motion, motion and position. You do not always have to see I'm going to try to do this here. Okay. So right here at the beginning of this, you do not always need to see something move to know that motion's taken place. In other words, if you ride the school bus to school, it drops you off in a certain spot. You come in the school, you don't see that bus move, but at the end of the day, when you get back on the bus to go home, it's in a different spot. We know motion has taken place. And that's what this is telling us. Hey, you don't have to see that motion happen to know that something moved, okay? How do we know it moved? Because we have a reference point. The school building, we know the school building's not going to move. And since we know the school building's not going to move, if the bus changes position, up here, position, if the bus changes position due to a due to a due to your reference point, the school, if the bus changes position due to your reference point, the school, we know it's moved, okay? Motion is a change in an object's motion is a change in an object's position relative to a reference point. Okay. Now, let's go over here. In a coordinate system, we have a north, south, east, and west. You've done these before, positive and negative from the starting point. I'm not going to go over all this. You can read this. All right. What is that change in position? Change in position. If I don't know if I can use this over here or not. Let's find out. Oh, we can. Okay. Beautiful. All right. So change in position. Distance. Okay. I know what it says here. I want you to know distance is the total path taken. Distance is the total path taken. Okay. If you were to go to Walmart from the school, you would have to go down the roads, drive down the roads. All right. That total path from the school to Walmart is the distance. Displacement, on the other hand, displacement is a straight line from point A to point B. So it would be a straight line from the school to Walmart. You wouldn't have to count all the roads and all that. Distance is the total path taken. Displacement is a straight line from point A to point B. Okay. Displacement also has to have a direction. So if you were at the school and you'd be going to Walmart, Walmart, I believe, is northwest of the school. So it would be a straight line from the school to Walmart with direction. Okay. And if we look at this person down here, if we check this person out, they start here. Okay. They're running all the way down the field, 50 meters, and they're coming back, and they're back at 20. So the distance here is 10, 20, 30, 40, 50, 60, 70, 80 meters. This person has run 80 meters. Their displacement, on the other hand, if they stop running right here, is point A to point B in a straight line. So here it would be 10, 20 meters. 20 meters, if we consider north, south, east, east, and west, they are 20 meters east from their starting point. I guess you stay on as we change pages. Let's get rid of them. Okay. Adding displacements. Adding displacements. right here, adding displacements. We'll just take a look at it, mess around with it. You know, you can add distance together if they're going in the same direction. I'm going to tell you this right here. This is what we're using. We're going to use motion in 2 dimensions. When we add this next dimension, you have to add some some calculus and some heavy algebra, so we don't mess with that. We're only doing this right here, okay? So adding displacements we can do. Speed is what I want to look at. Think back to the mail truck moving down the street. You could describe the movement by the distance traveled or by displacement. You might also want to describe how fast the truck is moving. That's saying how fast did that change take place, that movement take place, okay? When we do that, we're talking about speed. Speed is the distance an object travels per unit of time. This is how we calculate speed. Now, don't worry, we're going to have a worksheet coming up on this, and it'll make it a lot, I'd say, a little bit easier, okay? So speed in meters per second is the distance in meters and the time in seconds. Okay, and I'm going to give you a cheat sheet that has all this written down on it for your problems coming up. Okay, constant speed. Constant speed means, and if you look over here at a speedometer, you could go at a constant speed if it looks like 51 miles per hour there, okay? You could go at that constant speed with no problem at all. The thing of it is constant speed's a little bit rare because you're always going up hills, going down hills, turning corners, speeding up, slowing down. So constant speed is not, it's, if you have your cruise control and you're on a flat road with no hills and no curves, you can achieve a constant speed. Other than that, constant speed's a little bit tough to achieve, okay? Changing speeds, again, when we're driving, whether you're on your bike, you're walking, you're running, you're jogging, you're in a car, your speed changes all the time, okay? And since it's changing all the time, it's hard to say, hey, what's my speed right now? What's the speed here and there? So what we usually deal with is average speed. Average speed is one way to describe the speed of a bicycle trip. Average speed is the total distance divided by the total time of travel. And this is what we usually work with, okay, is average speed. Instantaneous speed is your speed at any given moment of time. There's only a couple different ways to get that. One of them is with a speedometer. It tells you your instantaneous speed or your speed at that one given moment in time. And a police's radar gun, and they will, slap that radar gun on you, and they know your speed at that given instant in time. Graphing motion, time. Remember, time is independent. Time's on the bottom, and the distance is going to be the dependent variable. So independent variable down here, which is always time. In this case, it's always going to be time and distance in meters. And the reason I'm pointing this out to you is you will do a graph, okay? Now, and this is just showing you your speed, your distance, time graph. Now, we're going to do a graph very soon. I'm going to show you how to do these in a lab we're going to do. And then I will give you a worksheet coming up on these reading distance time graphs. It's kind of like that worksheet we did with reading graphs. Okay, you're going to read distance time graphs, right? Hope this helps you with your homework. Section 2 will be next. Have a great day.